Okay, so let us continue the discussion about the tutorial problem. Now start with the inequality here, 5c. Okay, so we want to know what is the solution to the inequality absolute value of 2x squared minus 5 is less than or equal to 3. Okay. Okay, 5c. Oops. 5c. So the inequality is absolute value of 2x squared minus 5 less than or equal to 3. Here we have 2x squared minus 5 is in between minus 3 and 3. So the meaning is that we have 2x squared minus 5 is less than or equal to 3, and 2x squared minus 5. Okay, so I will use the implication sign there. Is greater than or equal to minus 3. So in this case, I have 2x squared minus 8 less than or equal to 0, and 2x squared minus 2 is greater than or equal to 0. Okay, in this case, I will have x squared minus 4 is less than or equal to 0, and x squared minus 1 is greater than or equal to 0. Of course, in the first inequality, I have x minus 2 multiplied by x plus 2 is less than or equal to 0. And in this case, I have minus 2 and 2. Okay, and then we should check the sign of this one. Okay, the sign of this one is positive, negative, and positive. So I will take the negative part here. And another inequality is x squared minus 1 is greater than or equal to 0. And I have minus 1, 1 here, and the sign is positive, negative, and positive. Okay, so I have, since this is greater than or equal to 0, I have positive part here. Okay, so combining these two solution set, I will have, so I need to take the intersection between these two solution set. Okay, if we take the intersection, then okay, so graphically I have minus 2, minus 1, 0. Okay, more realistically 1, okay, 1 and 2 there. Okay, so first I have minus 2 until 2. Okay, probably stand a little bit. First minus 2 until 2 here. And then the second one, I have minus 1, 0, 1 there. And then, of course, I will have this region. Okay, this region. So we're taking the intersection between these two means I have a region where there are two shaded area, the red one and the orange one. Okay, if we take the intersection, then we'll have, let's say, minus 2, minus 1, 0, 1, 2 here. So we have the intersection is this side. Yeah? Exactly this side. So the conclusion will be the solution set is the set x, for which x is in between minus 2 and 1. Sorry, minus 1 included minus 2 and minus 1, or x is in between 1 and 2. And in this case, I can rewrite this as the interval was in interval minus 2 comma minus 1 union with 1 comma 2. 1 comma 2. Okay, so that's the solution set. This one. Okay. All right. Now, what happened if I... Okay. Okay. Previously, you have seen the geometric interpretation to this part. Then, okay. Okay, I will repeat once again. If I have now, where is the plot online? Okay. Okay, this one. Then I have, this is the picture. So you see that the black curve is the graph of the function absolute value of 2x squared minus 5. And then the red line is the line y equals to 3. So the inequalities, the inequality absolute value of 2x squared minus 5 is less than or equal to 3 correspond to the area or the region where the black curve is below the line, the red line. Okay? So in this case, I have the region is minus 2 until minus 1 here, is to minus 1, and then 1 until 2. Okay? So that's why the solution is the union between the interval minus 2 comma 1 minus 1 and the interval 1 comma 2. Okay. Okay. So now that's the solution. So now let us continue to the next question. Okay. Let us continue to the next problem. Okay. Now we consider 5D. Okay. So in 5D, we need to solve the inequality absolute value of x over x minus 2 minus 3 over, sorry, x over x minus 1, I guess. Okay. Minus 3 over 2 is less than or equal to half. Okay. Of course, in this case, we will have x over x minus 1 minus 3 over 2 is less than half, and x over x minus 1 minus 3 over 2 is greater than or equal to minus half. Okay. So this is equivalent. All right. Now, of course, we should solve this inequality one by one, and then, okay, be careful. I should to be clear, greater than or equal to minus half. Okay, I will solve the inequality one by one, and then take the intersection between the solution of these two inequalities. The intersection between the solution to this inequality. Okay, so for the first one, I can simplify x over x minus 1. That will be minus 1 is less than 0. And this is equivalent with x minus 1 over x minus 1 less than 0. Yeah? And this equivalent with, if I simplify this, becomes 1 over x minus 1 is less than 0. So if you have this guy, then oops, sorry, looks like I make a mistake here. It's minus 2 here. Okay. Oops. minus 2. Okay, minus 2 everywhere. So I will get x minus 1 as a denominator, and then I have 2 minus x. Okay, it's less than 0. So if we consider this inequality on the real line, I will have 1 and 2 on the real line. Then I should check the sign of this expression. Okay, start with x is less than 1. We may take the sample point x equals 0. And in that case, I have the sign is negative there. And if x equals to 1/2 there, the sign is positive. The sign is positive. X equals to 3, for example. The sign will be negative. Okay, so the solution set from the first inequality is the union between interval minus infinity, comma 1 and 2, comma infinity. Okay, so now let us move to the second inequality. In the second inequality, I have x over x minus 1 minus 3 over 2 is greater than or equal to minus half. Okay. And if I add it by half there, I will have x over x minus 1 minus 1 is greater than 0. Okay. Simplify it to be equivalent with x over x minus 1 minus x minus 1 greater than 0. And this becomes 1 over x minus 1, right? Is greater than 0. So the conclusion will be x minus 1 should be greater than 0. So, or s is greater than 1. Okay. So on the real line, the solution set will be here. Okay, of course, you can take plus sign there, and then we should take the intersection between these two. And the intersection will be, okay, so the solution set is the set of point x. Okay, so let us take a look at this. X is greater than or equal to 2. Or I can write it as the interval 2 comma infinity. Okay. All right. Okay. So the next one. Okay. 5e. Okay. For 5e here, I have the inequality absolute value of x plus 2, right, is less than absolute value of 2x minus 3. Okay. Actually, we cannot solve this directly as the earlier question, but we recall that the absolute value of x equals to square root of x squared. Okay, by the monotonicity of the square root of x, of course, to find the solution, then we can actually take the the square of this two. Okay, it's equivalent with x plus 2 squared. Okay, x plus 2 squared is then absolute value of 2x minus 3 squared. Okay. Okay, and then next one, if I consider this, if I take the square of this, then I get x squared plus 4x plus 4 is less than 4x squared minus 12x, right? Plus 9. Okay. Okay, of course, we can simplify this to become 3x squared minus 16x plus 5 is greater than 0. Okay. Okay, so now what happened with this one? Of course, okay, so I will copy the quadratic inequality, the last quadratic inequality down there, minus 16x plus 5 is greater than 0. So 3x x minus 5 is minus 1. Okay, is greater than 0. Of course, we can consider here 1 over 3, 5 here. And then we should check the sign of this. Sign is plus, minus, plus. Of course, we take the sign with the positive sign, the area with the positive sign. So in this case, the solution of the solution set is set of solution x, where x is less than or equal to 1 over 3, or x is greater than 5. Oops, it's not equal because there is no equal sign there. Okay, or you can write it in terms of open interval minus infinity over 1 over 30. Okay, so I will put the interval notation just down below here. Minus infinity, comma 1 over 3. Five. Sorry, 5, right? 5 comma infinity. All right. Okay, so let us resume the discussion about the solution to this tutorial problem. So we have discussed number 4 and 5, and now we want to continue with number 6. So actually, it's quite kind of straightforward. For example, if you on this consider 6a here, so the question is to determine the equation of line here. In particular, the line pass through the point 2, 3, and suppose that its gradient is minus 2. Okay, so here in 6a, so the line passed through the point 2, 3, and its gradient is minus 2. Okay, so can use the equation y minus y0 equals to m times x minus x0. Here x0 is 2, y0 is 3, and m equals to minus 2. So in this case, I will have y minus 3. Okay, just make sure first, equals to 2 times x. Sorry, this is minus 2, x minus 2. So I have y equals to minus 2x plus 4 plus 3. So minus 2x plus 7. Of course, we may check our answer just we can verify it by checking, for example, if I put y0 equals to 3, 3 equals to minus 2 times 2 plus 7, and this is actually correct. Okay, so that's the equation of the line given a point, and given a point on the line, and also the gradient. Okay, so the next one in 6b, we are given the following condition. The line passed through 2 points. The first one -1, 3, and the second one is 2, 5. Okay, so in this case, okay, if we are given 2 points on the line, then of course we can find its a gradient. Okay, so the gradient of the line is m equals to 5 minus 3 divided by 2 minus 1. Okay, that will be 2 over 3. Okay, so the gradient is 2 over 3. Okay, so once we get the gradient, then we can find the equation of the line just like the previous equation. Take the one of these 2 point, and then the information about the gradient, then we get the result. Okay, so more precisely, the equation will be y equals to, the gradient m is 2 over 3, so 2 over 3 multiplied by x minus 2 plus 5. Okay. And you can see this becomes 2 over 3 x minus 4 over 3, and that will be plus 4 2 over 3. Oops. Sorry. Plus 3 2 over 3. Okay. So because 4 over 3 is just 1 over 3, so we get this one. Okay, so all right, we obtain the equation of the line given 2 points on the line. Okay, let's find the gradient, and then once we get the gradient, just choose one of these 2 points, and then doing exactly the same procedure as as the previous equation. Okay, all right, so now we continue to 6c. 6c here, we are given a point on the line, and also the information that the line is parallel to another line. More precisely, okay, C, the line through the point, what is the point? 1, minus 2, and it is parallel to the line 2y equals to 3x plus 10. Okay, that's information. Now we'll see that here, of course, if we have 2 lines that parallel to each other, then the information is that their gradient are the same. Okay, so in this case, first we have to looking for the gradient. So from the equation 2y equals to 3x plus 10, we know that y equals to 3 over 2x plus 5, and in this case, we have the gradient is 3 over 2. Okay, so m equals to 3 over 2. So just use this information, and the point 1, comma minus 2 exactly as in the equation A. Then we can find the equation of the line. Okay, precisely we have y So I will write it completely. So the equation of the given line is y equals to 3 over 2 times x minus 1 minus 2. Okay. Of course, you can simplify it. So this one equals to 3 over 2x minus 3, 1 over 2. Okay. Okay, so that's the equation of the line. All right. So that's 6c. Now we continue to 6d. The information for 6d is that we are given a point on the line, but now the line is perpendicular to another line, 2x plus 3y equals to 5. Okay, so okay, I will write the information for 6d through the point 2, 1 and is perpendicular to the line 2x plus 3y equals to 5. Okay. Okay. So if we have two lines that are perpendicular to each other, then the product of the gradients, the product for of each gradient is equals to -1. Okay. Okay. So since the line is perpendicular to this line, okay, first let us find the gradient. So the gradient will be, okay, we can write it as y equals to minus 2 over 3x plus 5. Okay, so the gradient of the line in the question is, because the product with minus 2 over 3 is -1, so is exactly -1 divided by minus 2 over 3. And that will be the gradient is 3 over 2. Okay. So the gradient is 3 over 2, and then it passed through the point here, 2, 1. So the equation of the line is y equals to, the gradient is 3 over 2. And then I have x minus 2 plus 1 here. Okay, so I can simplify this as 3 over 2x minus 3 plus 1, so it's minus 2. Okay. All right. So we have answer the number 6 here. Okay. And okay, so let us continue to the number 7, perhaps. Just the idea. Okay, so the idea is that here, okay, now here we want to know what is the relation between the degree Celsius and degree Fahrenheit. Here we have 0 degree Celsius equals to 32 degree Fahrenheit, and 100 degree Celsius equals to 212 degree Fahrenheit. Okay. Now we want to find the equation relating the Celsius and Fahrenheit here. Okay. Actually, we can view this problem as follows. So we may consider Celsius or Fahrenheit as x or y axis. So does not matter. Degree Celsius, degree Fahrenheit. For Celsius, 0 degree Celsius correspond to 32 degree Fahrenheit. Okay, so if 0 will be 32, so we have point 0, 32 there, and then when we have 100 degrees Celsius, we have 212 degree Fahrenheit. So we have also another point here is 100, 212. Okay, of course, we should look for the formula or the equation of this line. Okay, of course, if we are given 2 points here, then we can obtain the gradient. Gradient is easily m. So the gradient of the line is m, let's say, equals to 212 minus 32 divided by 100 minus 10. And that will be 180 over 100. Okay, divided by 20, we get 9 over 5. Okay, so the gradient is 9 over 5. Should be steeper but this. Okay, so the gradient is 9 over 5. So once we have the gradient, then just choose any one of these 2 points to obtain the equation of the line. Okay, so in this case, I have f, so degree in the y-axis equals to 9 over 5. Probably just a degree there, just for the notation. Degree Celsius minus 0. Okay, because to the point plus 32 there. So I have 9 over 5 degrees Celsius plus 32. Okay, that will be the formula. Okay. Okay. Okay, so now we want to convert 100 degree Fahrenheit to the Celsius here. Okay, if degree Fahrenheit is 100, then we'll put 100 there, 9 over 500 Celsius plus 32. Just subtract this by, so degree Celsius will be 5 over 9, right? Multiply by 100 minus 32. Okay. And that will be 68. Okay. 5 over 9 times 68. And that will be 68 times 5. 0, 4. Okay, so 340 divided by 9 degrees Celsius. Okay. That will be the answer. Okay. Okay, I think that's all for this equation of the line. We'll continue again in the next part of the tutorial about the equation of the circle and also about the domain and the range of the function. Okay.